this working? I think this is working. What's up, goobers? Woo! I was finishing up eating my chicken tendies. Why is my face... Oh, I know why my face is lagging so much. Because I have my VPN on my phone. Let me go turn off that VPN. Wait, the VPN's already off, though? Am I on the wrong Wi-Fi network? Test 1, 2, 3. Nope. Okay, I think that's actually working. No, that's still laggy. What is going on? Okay, why is my Wi-Fi 6 network the one that's, like, super slow right now? Okay, we'll just try the normal one. Low-key, Wi-Fi 6 has just not been terribly reliable for me. I kind of like the 5 gigahertz band a bit more. But let's see. Okay, let's try now. Oh yeah, that is so much better. What's up, goobers? Yeah. Let's see. Yeah, I've been pretty good lately. Just working on projects. Made a bit of progress on the CRADLE of PILLTH, which we're gonna be working on today. Between today and the stream on Tuesday, everything is turning out really good on that. Yeah, my sleep schedule's just been kind of wonky. Like, I literally woke up 2 hours ago, and for reference, it is currently 7 p.m. in Texas. It is dinner time, and I woke up like 2 hours ago. So yeah, hopefully my schedule will be kind of back to normal-ish. I mean, I have a contract that should be starting very soon. So once that actually starts, because like literally all the paperwork and stuff is done, it's just scheduling my first day, which I'm waiting on. Once that's done, then my sleep schedule will have to conform to that. But for now, I just sleep whenever I want to and wake up whenever I want to. But yeah. Let's see. I ate chicken tendies and tots, and I just took my ADHD meds, so kind of scatterbrained right now. My cat is here again, and he is being very polite, and he's sitting in the futon instead of in the area that he gets stepped on, so that's good. Let's see, my iPad has enough battery. Okay, yeah, I can show. I'll go show. No, my iPad's dead actually. RIP. I was gonna go do that live video thing again, but it's a pain in the ass to set up right now. I need to figure out like a more streamlined solution for that. We can charge it up and then show the kitty later. Okay, so let's see. Oh, I wanted to give some updates on my assistant. Let me go put her on ignore mode for now, because whenever I say her name, she responds. Okay. Turn off wake word detection. Okay, so yeah, Ritsuko, my AI assistant I've been working on. I figured out how to make her 3 times more efficient now on token spending. Because I want her to run completely locally eventually, and right now, 4 of her functions which require some kind of AI component are running completely locally on a very low power Mac Mini. So, yeah, that just means that I have total control over my data in privacy, and I don't have to pay any bullshit subscriptions, and I'm not adding to, like, data center power and water usage requirements and stuff. And soon the last part, which is her logic, although that's also the biggest part, will be local also. I I've just been kind of benchmarking some stuff and figured out how to shrink her instructions significantly down to where she only needs specific instructions when needed, instead of basically having to read the entire instruction manual every time I ask her a question or tell her to put something on my to-do list or need a reminder. Because that is really wasteful. And I also found a bug where apparently my entire to-do list dating back from March was still being sent back to her every single request. And that was a lot. That's like 200 tasks that have been knocked off the to-do list that were still being sent to her, because she was starting to get really confused with like bringing up like ghost tasks and like stuff that I finished like weeks ago, and it's like, oh, she's looking at the stuff I finished ages ago. So yeah, that's been fixed, and now she's a lot more efficient, and hopefully by the end of the year I can have her running completely locally, and then I'll have total control over her model and not have to pay any subscriptions, and she'll be eco-friendly, and she won't be beholden to any corporation's bullshit, and yeah, everything will be nice. This is the good end for AI, not the bad end where we're all stuck with it and stuck with subscription fees, and we own nothing and run everything, and the corporations that take everything we do. But yeah, okay. So enough about the assistant. Let's go back to the Cradle of Pilth. Okay, so go to the office. Oh, Miyoki, I'm really sorry about forgetting to follow up after Tuesday. I've just been kind of scatterbrained lately. Honestly, just keep reminding me until like I'll try to actually. This is the perfect use case. Okay, let me turn on her wake word detection again. Detection. And turn off sleep mode. Ritsuko, add reminder to follow up on Discord in 4 hours. Cool, thanks.
No problem. Catch you later.
Okay, yeah. I think you could hear her. She lives on my ceiling. The Mac Mini's also on the ceiling. Her cameras and speakers are on the ceiling too. Her monitor, which is an old 21-inch 1920 by 1080p monitor, is mounted vertically on the ceiling also. But yeah. Okay, let's get to the Cradle of Pilth. Okay, I should probably open up Fusion first. Okay, so last stream, we were working on... Oh, camera's not connected. Let's turn that on. Come on, Fusion. Alright. So, last stream, we ended with this one print, starting to finish, and the roller being molded. It needs to take a bit to cook when it first opens. Okay, cool. So let's open that, and let's also open the roller hub. Okay, so... yeah, so this is what we were molding at the end of last stream. It's basically just like a really, really wide wheel, or you could kind of imagine as like 5 wheels stacked together. The center is hard 3D printed plastic, and the outside is urethane. It's a very rubbery, frictiony material, way grippier than anything you can 3D print, which is why we're bothering to even mold it instead of 3D printing it. We created a mold for it, so that we could pour in, so that we would take this hub, we'd pour in the liquid urethane, the rubbery material for the tire compound, and then this is actually like double-sided. I just hid one of those sides for visibility. Or wait, I think there's actually a better way to like make it like look kind of ghosty. Oh yeah, yeah. So you can actually make it look kind of ghosty if you do that. Okay, that's cool. Didn't know that. That's useful. So yeah, we'd pour in the mold and then, or pour in the rubber or the urethane in the mold and then let it do its thing for like 24 hours, and then by the end of it, we have this. And yeah. Oh, and the other part is we have the whole assembly of the thing, which looked like this-ish, I think, when we last finished streaming. Oh, forgot to put the shaft in here. Let's turn that back on. Yeah, here's the shaft. I only want to update one of these right now. Where's the update thing? There. I don't know why that get latest thing lags a bit. But yeah, we have this thing, which goes up and down. I don't really know how to model springs properly, so I'm just doing a thing where, like, if it starts to go through itself like that, or if it, like, detaches, that's probably safe limits, I guess. But yeah, so we have the roller going on this, technically don't know if this is actually a lever. I mean, like, it acts like a lever because it has, like, a fulcrum, but, like, I don't know if it actually performs like a lever in terms of... I guess it does, because we're applying some mechanical advantage. But anyway, yeah, so we have this lever with the, roller on it, and, this part we're not really gonna use, so we can hide that body. Yeah, so I printed this out, and assembled it, and, oh, this part here is a circuit board for a sensor that detects when this is spinning around. It does this by, there's down here on the bottom of the, or I guess on this one, on this end. Oh, Fusion's offline. That's weird. Is my internet still on? Hold on. Let me just sanity check, because it said that Fusion is offline, which means one of two things. Either Autodesk is failing and everything else is fine, or my connection is dying and the stream will have to be killed early. If any of y'all can reply in the comments if the stream is still alive. Test. Okay, well, I can speed test, I guess. My internet connection looks fine. And it says that I have no drop frame, says the connection's good. Restream says that my connection's good. I'm gonna assume that my connection's good and keep streaming. Not bad. I do wish I had symmetrical upload and download, but yeah, didn't roll the dice properly on this condo with that. But okay, it looks like my stream is actually working fine though still. Okay, so let's get back to this. So down here in one of the ends, because this one's just solid, this one has a little dent in it. We should actually probably name these. I'll call this shaft. And I'll call this one magnet. And this is part of the mold. So yeah, there's a little magnet in here, and the way it's split is kind of like a pill, or like a tablet, where like one side is north and the other side is south. And so when it spins around, the positions of north and south spin around too. And then the magnet is here, and this white piece is actually a sensor that detects how much the magnet's spinning around. And so we take the pills, and they just get slid through this. The spring keeps it kind of clamped on. The rollers keep it nice and frictiony so that it actually spins when stuff goes through it. And because we have all these different funny lumpy sizes and shapes of pills, the springs allow it to, I guess, have some like kind of suspension so that it can like have variable sizes of things passing through it. And so this design almost worked, except for this piece here, which was added for stability, was kind of too fragile, and when I thickened it up, it started getting in the way of this, so I redesigned that just a little bit. Let's get latest. Oh, can't update it? Oh, it's because Fusion's offline, I guess. Boo! Oh, I know, I think I know what's going on, possibly. Okay, let me go see what's up with Fusion right now. But if Fusion is down, that's okay. There's other stuff that I want to do. Autodesk Health Dashboard. Please don't tell me I have to log in to see this. Huh. It says that Fusion's operational, so maybe I'll just restart it. Okay, let's just try restarting this. Come on, go online. Okay, I think we're back online. Alright, well that's good. Okay, so let's open up the linkage thing that I was talking about. Okay, so the update to it is, instead of having that tiny little beam here, that would get in the way of that, let's update it. Now we got rid of that beam thing, and we have this handle here that actually also makes it easier to load and unload the medicine. And it is well out of the way while still providing stability to it. And so, where are the meds? Yeah, here's a roll of meds. Okay, so now that we go back to IRL, here it is, the printed version of it. It's real. The mold, it worked pretty well. There's a bit of a seam here, but that's not going to affect the functionality of it. Springs, it's a good thing that we put those holes in there so that we can adjust the tension. and I played with a few different springs and found one that was the right amount of tension across all of the different sizes that could be going. So yeah, spins around like this. It's not the freest spinning. It could use bearings, but it's not super important because we're not really detecting exactly how much we're pulling out on the meds. We're just detecting if we're pulling out meds at all for the day. And I actually decided I did want to have this flipped around so that the PCB's back is against the magnet and the sensor is exposed, just so that we can actually see the pinouts of what we're soldering easier. And so if we take our meds, and then we just do that, and then it's a bit tricky to hold, but yeah, it's definitely spinning. You can see the rollers. It'd probably help if I turn the light on. You can see the rollers are rolling, and it doesn't catch on anything, and it works pretty well. So yeah, that's good. So yeah, there's plenty of stuff to do at this point right now. Trying to figure out what I want to do right now, because past two streams have been all, I think CAD stuff. Oh yeah. So I showed the 4-bottle, holder thing, and I actually reduced it down to 3 and reprinted it, and there's a reason for that. Okay, so let me get the packaging for this. So the pill packs, they ship in the standard box. And, yeah. So they always ship in a package that looks like this, and you just put it on, like, your shelf or whatever, and you just pull out meds as you need to. Let's zoom this out, actually. Yeah. So you can just pull out meds as you need to. The roll is all self-contained inside of there. And what I want to do is have it so that we take the sleeve, just take it off, and then we take the sensor, and we just put it up here-ish, and then we just roll the meds through this. So imagine this is actually attached to the box, like it has some kind of like a mount, and then this is really slippery to hold because there's not really any good surfaces to grab on it, and then it just lives on the box or around the box somehow, and we just pull meds through it. And yeah, and it's not a coincidence that this is the correct width for this box, because the box is literally made for the pill pack, and the roller thing and the sensor are made for the pill pack. So adapting it to the box should be really easy. Also, this is just a box. This is super easy to model around. And so what does that have to do with the pill bottle holders? So the 4-bottle mount, there's actually nothing wrong with it, and I kind of feel a bit bad because it felt a little wasteful to redo it. But I realized if I wanted this to be kind of a streamlined package, this 4-bottle thing might actually be too big. So if you have 3 bottles here, then we can make it more streamlined. And I just realized that we can't actually butt it up right against this because the tops of the bottles may conflict a bit with the mechanism. So we have to offset it, and we have to tilt it. Tilting, yeah, I think I like tilting. It's kind of elegant, I think. Yeah, that's not bad. And then, just somewhere, maybe, probably on the bottom here, we'll have the, where the electronics live. And electronics are gonna be super simple. You're not gonna go crazy on this. So, yeah. Let's see, let's figure out what the to-do list, I guess, is for the Cradle of Pilth so far. Okay, let's turn on air server. And then Kitty cat. He's still here. Okay. There we go. That's upside down for some reason. Okay, let's just turn around. Why is it still upside down? Oh, I need to rotate it. Okay. So, yeah. Oh no, this is, AI planning stuff. Let's go back to the Cradle of Pilth. Here. Okay, yeah. So you can see the old drawings at first I was just gonna put it on spool and we'd just, like, spin it around, and I didn't like that in the end. Oh, you know, I think that when I actually wrote those original plans, they were upside down to begin with. Okay. And then here is the roller mechanism that we turned into a real thing. It looks pretty close to what we ended up with on the actual model. And so, let's see. Cradle of Pilth to do. So, we need to model the box holder and overall housing. We need to wire up electronics. And we need to code it. Yeah. So, how do I want to do this? Because there's lots of ways that we can go about it. So, being realistic, while the box thingy is really easy to model, it's also gonna take a while to print, and we're definitely not gonna have it printed by the end of the stream. So, relying on that to be finished and ready to play with is kind of out of question. And that's gonna have to wait till Sunday to actually do the full assembly. If I do the wiring early and then start to work on the programming for it, then we run at the risk of having to rewire stuff again anyway, because wires are too long or too short. If we go too short, then we have to throw away the current ones or splice them in and then solder them. That's just going to be kind of messy. And if we go too long, then we have to cut off slack wire or bundle it up. I think that bundling up is probably the least worst. I don't like wasting wire, but sometimes you can't really avoid it. Well, I guess you can if you plan ahead of time and you decide to print out the enclosure first before wiring it up. And then coding it requires the electronics to be wired up to it. We can plan out the electronics too, though. So, yeah, I think that it probably makes sense to plan out the electronics now. And then we model the box holder and the overall housing for it, or at least most of it, just getting the layout. And then after that, we can estimate the wire lengths and add like maybe just a few centimeters of slack to it, so that we're not really wasting that much. And then we can code it together, and this will probably be Sunday. And 1 and 2 will definitely be able to knock out this stream, and 3 maybe towards the end, depending on how focused I am, or if I want to work on something else. But yeah, okay. So let's talk electronics. Okay. So first, I need to figure out how to actually wire that sensor up. I think it's I2C. Okay, what is the model of that encoder? It'll probably say the model number. It does not say the model number. Okay, let's look at it under the magnifying glass. This is an AS5600. Okay, AS5600, Ada fruit. Well, the wiring is a little bit different. Is it? Is that different? No, it's... Huh. It is different. I have to find, the specific one that I'm using. Yeah, this looks like the exact one that I was using. Okay, interesting. So, I guess if we can trust this random eBay listings pinout, which I don't know why we... I mean, it's pretty simple. This is kind of hard to fuck up. I'll go save that. And this is just a really generic one. Let's see if there's, like, more documentation or library here. But I have a feeling that we don't need to use all of these. We could use just, obviously, ground and power, and then use, SCL and SDA. That's my guess. Let me just see. I squared C library. Okay, so this always has specific address and it cannot be changed. We must use SDA and SCL and obviously power. And then we don't need to connect the direction pin because it has a default already. And we can use the out pin, but we don't need to. So yeah, this is, we only need to use 4 of the wires here. And ground and power are going to be kind of a given. So what is this? This is AS5600 encoder, and we just need to do the I squared C to whatever microcontroller we're using, which, let's be honest, it'll probably just be a ESP32. Since I have, like, so many of these. And then we have the pill bottle micro switches. Actually, yeah, the switch symbol is, like, super easy. Why is erase not working? So, yeah. How do I want to do this? Maybe let's make this one red for, power. And then let's do, like, a, kind of like a tan. Can I drag this color in as, like, a custom one? We'll just do brown for, like, ground. Okay. So, let's see. We have all of the, thingies, all the switches. And so I think that the ESP32C3 pull-up. Okay, so we do have pull-up and pull-down built in to that. So that's good. That means that we can simplify the wiring, and we can just do, like, forgot if it's ground or if it's positive, but it'll be one of those. We'll just make it yellow. We'll just have, like, a shared power source thingy. And then each of those will get its own line into the ESP32. So basically, anytime we close one of these switches, let's assume that yellow is, say, power, and these are all doing, like, pull down. Which, I know, we could also just enforce pull down. Where's brown? Let's go with that for brown. Let's just say that's all pull down. I'll just draw it in the diagram anyway. Oh wait, they'd all need resistors. This looks very messy, by the way. I forgot to do the, that thing, yeah. So that's gonna be some kind of R, and that's gonna be some kind of R. And then let's go back to brown. So then we have ground there. And then, let's see, does the ESP32, does the shell layout have enough pins for what I want to do? It should. Okay, so if we're gonna use that, okay, yeah, so we can use all of those ones, and we still have quite a few left over. I do want to add a screen for debugging, but it's not necessary, but that would literally just use the I2 seed also. And then, I think... So that's not actually using any additional lines because I2C is shared. I think that means we have, 1, 2, 3... We have 5 thingies left. And so, next one's easy. I'm just gonna have, something for a buzzer. What does the symbol for buzzer look like? Okay. So, it looks kind of like a funny bowl thing. Yeah, I don't think I've ever actually seen that. So we have a buzzer, and then we could have like a power LED somewhere. Yeah. I think that's the correct direction for it. Anyway. So yeah, it's a pretty simple layout. Not really doing anything fancy here. Okay, well, I guess that's done. Plan on the electronics. Okay, so I guess next thing is, model the box holder and the overall housing. Okay. So, easiest thing to do is just make a box. My caliper is big enough for the whole box. They barely are. Okay, cool. Alright, so we're looking at what's the laziest way to do this? Let's go from the bottom first. We're looking at, let's tilt this, 78. Let's make that 79, actually. We're just gonna round up a little bit. 79 by 151. And that's from the top. $79, 151. And then let's do an offset of, say, 1 millimeter, negative 1 millimeter. Okay. And then let's make that 1 millimeter. And then let's get the height of the box. Height of the box is 148. So it's not a perfect square. Let's round that up to 149. There we go. Nope. How did I fuck this up? It's supposed to be, like, really easy. Okay, okay. I see what's going on. So we have that, and then we can make this one 149, and join. Okay, so we have our pillbox. And we can drop that into the assembly. Yeah, let's rotate it. Let's move it down. And then that means that everything else we kind of design will be kind of dictated around this box. And I think that also means we need to ground that. Unground that. And then these are all going to be kind of wacky. And I'm just going to hide the packets for now. But yeah, so we need a way to interface that. And we have all these holes down here, which will make it very easy to extend that with. So I'm thinking that we just, from here, we just kind of like model the box's silhouette. And then we have a plate that attaches to it, because all those holes are meant for attachment plates, so we don't have to reprint the whole thing. It's modular. So what was that? That was 79 by 151. So let's get the base of this. Okay, so sketch here. From the center of that, and then you're going to be 79, and you're going to be 151. And we're going to ghost you. Okay, so if we line that up, then that means that the plate needs to be just a bit bigger than this. Oh no. Let's actually offset that by, say, 4 millimeters, I think, is probably, or actually, whatever this is, that is 89, 79, let's make it 5 millimeters. So that it actually just lines up really neatly with this thing. And then let's also offset this just a little bit. 0.5, just give it a little bit of tolerance, especially since, like, cardboard, so, yeah. And we don't need to use all these holes. We're probably gonna have to ignore these holes because they're too close to the edge to really use, I think. So if we line that up, yeah, I think this is looking good. Then let's take this and also fill that in. Let's also add the cutoff here. So this entire section will be just wide open. Well, actually, I think we might want a little bit of a lip just to retain it in, so that it doesn't really, like, slide off in some weird way. So let's make that like 5. Yeah. Okay. So let's see. I want to take this entire thing. Not these holes, because we'll use that to actually mount it on. But we'll take this And we'll extrude it maybe 5 millimeters. That should be pretty robust. New body. Okay, cool. So this... I'm just gonna keep referencing it over and over so that we can see what's going on. Okay, so we have this, and it's being all wacky and wandering around. And let's also color stuff so that we don't get confused. Okay, so appearances, let's just make this like some kind of white, I guess. Powder coat, rough, sure. Is that working? Why can't I apply that? I guess I have to download the material? Okay. Anyway. Okay, so that's white. Let's... Oops. Let's constrain that face to this face. Oh, this is really wacky. And then let's constrain... not that edge. Okay, let's constrain this to this with an offset of 5. And then we can do the same thing on the other one. Okay, so this is how it would be sitting on that. We don't have the thingy that envelops it, and that's the next part to do, I think. And then if we hide the box, then it's just gonna be... honestly, this thing's not gonna be high load. We could get away with probably 3 screws instead of all 6. But yeah, so that would just fit in here, and then... I want to take the pill bottle ring thing. And, oh, why did that spin? Just kind of roughly place it where I think it's gonna go. So, I'm feeling something kind of like this. And, well, actually, let's just simplify it first. Let's just keep it straight, like that. So if we do this, then it would actually be pretty easy to make, like, a little ledge feature for this to just kind of slip under and mount with those 3 holes. And then that means that all we need then is, so we need a way to connect this to this, which we'll just extend that, add those holes. And then we need a way for this to wrap around and hold the box, hopefully in a way that doesn't require screwing and unscrewing. We just slide it in and out. Just make the changes of the box frictionless every month when the new box comes in. And then I think the electronics, they're gonna be super simple, and they're just gonna like live down here, probably just some little box that we can add some like... we don't have to design that right now. We can just add some holes in there, some mounting holes, and then print out a separate little module for that. And then just some generic features so that we can wall mount this, or we can attach this to her, or we can put on my desk, or just anything like that. I think that... oh, shit. I have not been streaming that. What the heck? Okay. So, what did I do? I have to go back and kind of go back to where I was at. Okay, so, after designing those electronics, I measured the box here, and then, yeah, just this box here that holds all the pill pack things, and then... pop that into the model and kind of visualized how the sensor, the Rolly sensor, is going to fit on top of that. And then on the Rolly sensors, base, we made this little base plate here. And you know, if I actually put the pillbox on the other side, that means that we can, because the wiring for this is on that side, and it's not reversible, I don't think. Yeah, it's not reversible. So we might actually want to put that on the other side, just so that we can keep the wiring neat. Why can't I move this? I'll just place it back in. Okay. So here... this is kind of where I imagine the pills sit. And we already have some mounting holes here, so all we need is just extend this plate out, and then put those holes in. And honestly, we could just make a big flat plate with a bunch of holes so that we can redesign the cradle to how we want to. I think I want to do that. That's just going to be easier to print and stuff. But yeah, let's just take this, maybe just kind of visually line it up like that. So then this will actually be going over that, and then we'll have the holes on top, and then we'll just have wires going down this, and then a little electronics box down here, and then that means that we can put wall mounting and other stuff on this side and on the back. And I think that is sensible. Yeah. And then I think here I just want to extend whatever we're doing down here. Nah, that's not necessary. We'll do that at the end. Streamline it. Okay, so let's see. First, let's go to the pill bottle ring thing. And what is the distance between those? Min distance, okay, that's not helpful. From here to here, we have 100 millimeters. That's a nice, easy number. I think I actually want to line it up to here. Yeah, we'll just line it up anyway. Collinear. What? I have to project that, I guess. Okay. Well, I guess we're gonna have to project those anyway. Alright, so midway point. And then this is 100. And then the screw holes, just gonna fit M3. 0.5 here. Let's have that go. Deep should that go? Past that? Yeah, maybe just up to 5 millimeters. I don't think it's gonna be like high load. And then I think here, just gonna kind of overestimate just to be safe. Probably want it to be let's say 25 millimeters, 20 millimeters out. Okay. So let's extend that up to here and hide those bodies so it doesn't merge in. Okay. let's get latest. Bless me. Okay, so we have this now. And let's constrain those. And then here I can either go up or down. Doesn't really matter. At least I don't think it will matter. But let's just have it go down for now. And then we have the attachment for the pill bottle holders, and all the wiring just kind of flows through that. We're gonna need a hole here, though, for the encoder wire, so we can keep that nice and neat. That is strange. Are these not the same faces? Let's have it extend to object. Up to here. Oh no, now this is just one object again. Oh, I see what's going on. It's because we had two sketches going on. Okay. So let's put the hole down here, you think? And we'll make it big enough to fit like an entire GST XH connector. So let me go get one of those out. And I think that's the only component I want to do like a that I want to actually add kind of a connector on, and just hardwire the rest of them, just since this seems like something that may require some iteration to some. So we're looking at, we're gonna round up 13 by 6. Let's actually make that 14 by 7. Just so that it's nice and snug. Or not snug, nice and we've got room. Or, you know, we don't have to. I'll just do it in the sketch. Or that was 7 and I think 15. And just don't extrude. What? Oh, I see. Okay. Alright, that makes sense now. Cool. I think I have a bunch of, like, empty sketches. What? Okay, I'm not gonna mess with that. Okay, so you have a feature now for the wire to just go through there for the encoder stuff. And I think now it's just making the thing that wraps around the box. that look like? Because I don't just want to, like, do a big-ass 3D print that just surrounds the whole thing. And actually just keeping it simple, that might really be the best thing to do. Let's see. Honestly, that might just be the best thing to do. And we can just add some stuff in to make it... to save some filament, I guess. The only thing I'm kind of thinking of is how we want to lock the box into place. You could just use a simple, screw knob thing. I think I'll just use a simple screw knob that goes from the bottom and just makes the screw go up and down and just locks that box in place. And then up here will be like kind of a lip thing also that that'll help retain it, I guess. How do I want to do this? I think I'm actually just gonna... Okay, so let's just take this. And let's just beef that up a bit so that we have, like... No, actually, I don't want to do that. Let's actually do... this. Okay. So I'm thinking that we have an array of holes that we intend to use to attach the thing to. It's going to be slightly off center here because that one hole's in the way. Let's make that one just say 50 away from there. Oh, that should not be on that line. Okay, so those will all be equal. Let's make that like, I don't know, 3.5. Let's aim for using M3s for this, I guess. We'll make that tangent. We'll make that tangent. And then we'll have a bunch of these funky guys. And let's make them like, no, 10. Let's make you equal. Okay. And then just fill in those corners. There's only a few to fill in, really. I think it's only that one, really, that needed to be filled. Okay. So here we can extend all the parts that don't exist yet. And we'll just hide that thing just so that it stops interfering. We'll call this one sensor base, and we'll call this one box top plate, and we'll call this guide. Okay, and then yeah, we'll just make that kind of, yeah, like that. And then, I don't know what that one sketch is for, so I'll delete it. And then here, we'll go back to that one. And we'll just take out those holes. Okay, so you have this plate thing. And let's go back to the assembly. And now we have those features around it, and then we can make some kind of a funny little cage thing, I guess, that holds that in. Okay, so I'm kind of making the assumption that the source of truth, I guess, of, well, no, actually, that's kind of not necessary. Yeah. Oh, wait. Okay, yeah, that makes sense. So let me just sanity check with, yeah, so that's about the outline of the box. We're gonna make it just slightly bigger than the actual box. So it's like 79. Let's make that like... No, actually, I think that we already designed that to be, yeah. So we can just have that there. Pretty sure that just goes to there. And then whatever the distance of that is, it's 151. That should hold the pillbox. Actually, that's... Let's give it a little bit of wiggle. Oh, okay. Guess not. Yeah, sure, whatever. Close enough. Oh, yeah, it's already gonna wiggle that up. Okay, okay, okay. Cool. So, what I think I'm gonna do here is... This might be wacky. I think that I'm gonna have this go up. Oh, you know what? That side actually has to be flat anyway if we're gonna mount electronics on it, so we don't have to get too weird on that. Never mind. Oh, you know, actually I think so. Yeah, never mind. We're gonna be weird. Plus, I didn't want the design to look too boring anyway. Okay, so what was the height of that? I want to say it was 150-ish. And this is just going to be a new body. Actually, I don't want to deal with, like, accidental merges. I'm just going to do that tiny offset trick that I do, which probably makes real mechanical engineers scream. But it's okay. So the funny thing I was talking about that I want to do is just take that and just mirror it across itself. So then that is our holder thing. And then we're gonna have to cut out a bunch of holes in it to make it, like, efficient, I guess. But yeah. And it's okay if there's a bit of wiggle room here. So that's like 1mm wiggle room, that's acceptable. And so the electronics are really not going to be that big. They could probably just live entirely in this chunk, I think. So with that... I like how there's holes all the way, even though it's probably not necessary. And I'm just giving everything a really weird, funky color just so that they can be differentiated. I'm not going to be printing it out in, like, all these funny multicolors I'm doing. What's the color that we haven't really used? I'm gonna go with dark gray. Okay. Let's have this. And, I mean, the part that I'm kind of deliberating on is what side should be open and what side should we, like, load and unload stuff on. And if we can do things in panels. You know, I think I figured how we can save on... You can just exclude the top. Not the top. We can exclude the front. And the back here. And then let's see, let's add a mid-plane plane here. Okay. And then let's mirror this across here. Yes. And then we can do both of those sides separately and flat instead of standing up, because standing up takes more time to print. And then if we model these guys, then we can print a little lip here. That also leaves a bit of room for that to be assembled. So we'll have this one be like, say, 4. Yeah, just 4. And then similar lip thing going on here. .5-ish. What is this alignment? align it to this guy. Yeah, sure. Wait, what? And then here, let's just properly align you to here. Oh yeah, that needs to be collinear. Okay. And I think that should let us have a bit of a lip here. Okay, so let's see, how's this constrained now? The yellow plates only constrain it left to right, and then front to back, those little lip features that we just made constrain it that way. So now it's just from the bottom. So if we have a bottom loading thing, I think that a bottom loader would probably be in like a little slide plate, I think. Yeah, that's... I'm thinking that we do a slide plate thing. But... and I'll just turn that back on for visual reference. And we'll do the funny offset thing that I like to do. Hold on, I'm thinking. We could just go kind of extra thick on this. And then... because if these lip things are gonna be like 5 millimeters, then I think that means that if we remove at least 5 millimeters from this, then you'll be able to pull it out. And then this thing just kind of acts as like a kind of a shim. I think that would work. Yeah. Let's try that out. And then... in the worst case, the rest of this geometry is almost certainly still usable, and it's only the bottom geometry that we'd have to tweak and change. Could you do magnets? I don't want to mess with magnets right now. No, I actually have a shit ton of magnets. Let's do it. Let's go magnetic. That's gonna be the super easiest thing, actually, I think. Okay, where are the shit tons of magnets I just talked about having? Here they are. Okay, so I think that if we just use... No, I don't think they're gonna be strong enough. Even if we use like several of them put together. Okay, I just want to save this and just visualize it again. Okay, so we have this, and it's completely constrained, but we can't take the box out unless we undo 6 screws, which is a lot of friction. So, what if we had something like kind of a ramp here to kind of butt that up against there? I think I got it. I think I got how to do this. Maybe. Okay, so what's the width of this? That is 80 millimeters. Okay, let's hide those. Okay, so if that is 80, and let's just do like a symmetric feature here, I guess. And then let's have like a little bump thing here. And then let's have this be like, we can make the bottom part of that pretty thin and give this a lot of room to maneuver. Okay, so if we have this, then, you know, let's not actually fix the pillbox. Let's unground that. Ooh, that's weird. Okay, let's take the base actually, and let's fix the base. Ooh, that was not happy. Maybe update initial. Okay, whoa. Oh, I think I know what's going on. Because I hid the rest of the stuff. Okay, and then we can hide this. Okay, so what's the best way to look at this? I think if we take the base thing, can we set the opacity here, or is it only per body? Maybe we can just hide one side. Yeah, and then we can do like a section analysis thing. Or maybe you don't even need to do that. Where are the constraints on this? If I just delete that, and then put that back in. Okay. Cool, okay, yeah. Now we can visualize stuff. Okay. So, no, that's not gonna work. It's a good thing I visualized it. Well, actually, if we remove that one feature, yeah, let's just remove that. And then update this. Okay, so... oh, shit. Where did that go? Did we also kill that one face here? I think we did. Oops. Did not want to do that. We'll just do it the old way. Or no, actually... we don't need to waste the whole sketch for that, we just need to go find where we did that, which is just this one. Okay, so we'll just not extrude that one, and we will extrude that back one. Okay, so let's go back to this. And reload that model. Okay, I thought I see it. Okay, so that front lip is removed, and the back lip remains. And let's pretend that the yellow panel here is here, just kind of hidden. Then if we have this pillbox thing, then when it's pushed all the way back, that hump here forces it to go up. But when we pull it out, then it can go kind of down here. And we can keep pulling it out. You know, I don't think that actually makes sense. What I was thinking of. Yeah, that doesn't make sense. Shit. Wait a second. If that entire thing just slid, though... I think I'm overthinking this. Okay, let's get rid of that carve-out feature. And go back to this thing. Okay, so we reconstrain that, I guess. Oh wait, this is really simple. Yeah, I am overthinking this. Okay, so let's take that lip thing that I got rid of and let's put it back in. And let's make it 10, just for good measure. So I think all we need to do is just make a slider thing, so we can just slide this entire thing out and back in, and then we're good. It might be that simple. Oh, and we did give ourselves plenty of room also to avoid those screws. I'm just gonna project those just as guide reference or visual reference for how far to not put the thingies that we don't want. And then we can just keep it solid by... Okay, I think I got it. Hold on, let's extend this actually. Let's make it, say, 15. And then let's cut that lip down to just 5. So then that means in order to pass the box through, this needs to be at least 5 millimeters, probably more, just to be more comfy with it. This is 15, right? So if we have 10 millimeters shaved off, then this thing should have like a 5 millimeter gap, and it should be pretty easy to remove the box then. And we can also reinforce the back too. Okay, yeah. This is way easier than I was making it to be. Okay. So... going to just... carve out a little bit of this. Let's do 0.5 just so that things slide easily. And then we can actually use a magnet here also, just so that it's nice and tidy. And let's have this one be 10 millimeters, so that we have 5 millimeters on the bottom, so that we have some solid stuff on the bottom, I guess. So then if that gets extracted all the way, or extracted, that's not the right word, extruded, cut extruded, all the way there. And then we just project this. And then 0.5, cut that out. We have two separate bodies now. Let's color that in. And then we have this part, which we should be able to slide out and in. So let's see. Just want to sanity check this. Okay, so when the thingy's in place, it's constrained by all sides. Pretend that this yellow one is here. Can't move it around. Well, you shouldn't be able to move around right now. This corner is not... We could add a little lip here. I think I will. But it's not necessary because everything else is captured, so it'll just kind of wiggle, but it won't really, like, let it go. And then if we take that bit that I was talking about being like a slidey thing... where are you? So let's say that we pull that out, then we can drop this, then this will drop down, and then it clears the lip things, and then we can take it out. And then we can put this back in, we can add the slider, which should have a little wedgy thing so that it can just kind of push it up. And then it'll remain locked in place. And then we can use magnets to secure it. And in this case, the magnets will be sufficient for the use case. Yeah, cool. So first, just gonna design that lip feature I was talking about. Extrude U5. And then I was talking about that kind of wedge feature so that it moves the thingy up. Instead of a chamfer, let's just do like a kind of custom side profile thing. So we can't make it razor sharp or else it'll eventually break. So let's have that like a minimum of 1. And then this can just be really gradual. Let's make it 50 millimeters. And that should... Wow, that's weird. then we can round this out a lot. Cool. So that shim keeps it in place, and then we can add the magnet stuff, which I think I'll just hide underneath here. Yeah, that's like, what, 10 millimeters? Almost 10 millimeters. Okay. Let's see, I think I had some bigger ones that might work even a little bit better for this. Yeah, here they are. Alright, so these are some bigger magnets that I actually use for the OmniFixo project. And I think that probably just a single pair of these would be good enough actually for this. So we'll have them like this, and then it'll just snap in place like that. The only annoying part is that they're like kind of countersunk against each other, or they're not perfectly countersunk or something like that. Or what am I trying to say? One side is countersunk, but the other side is not. So if we have to have it so that like the magnets are kind of near each other, then we might need two magnets actually, just because we need some space, or because that increased space will weaken the magnet strength versus like if it's just right on top of each other. Let's see, I also do have a bunch of bar magnets though, I think. No, I use them all for battle bots. Never mind. Actually, well no, it's gonna have the same problem. Yeah, let's just use two pairs of magnets and just kind of deal with how we're gonna need, like, how it's gonna need some of that separation, I guess. But yeah, let's take a single one of these. So which one's the thicker one? Thicker part is definitely a ship. Okay, so thicker part is the shim, so that will have the magnets that are not countersunk. So it's gonna be 15 millimeters. I also could just epoxy the magnets in. Yeah, let's actually just count on epoxying the magnets in. And epoxy is easy as sand also, so... yeah, we can just do that. Okay, so it's not gonna be that deep, I just wanted to remember to do that, but the actual magnet thickness is about 3 millimeters, and let's see what happens if we... I mean, I don't really want to drive the countersunk M3s into it, because, like, we're not gonna have that much to grip anyway. I mean, we might... yeah, actually, I think we will, and then we'll just combine that with epoxy. Because if that's 10, or if that's 9.5 millimeters, yeah, that's actually okay. So, let's see. I guess that we can assume that with the added height of a countersunk bolt, that'll be about 4 millimeters. let's think it maybe 4.5 millimeters. Okay. I need to use the bathroom real quick. I'm gonna start an ad break because I need to poop. Okay, I'm back. Alright, so what are we working on? Magnet mounting points. Yeah, magnets can be the cleanest way to do this. I'm happy about magnets. Okay, so this can just go all the way through there. 5 millimeters. And then... yeah, we can just model magnets. Yeah, I'll just model magnets now. Why not? With the simulated screw heads. So that'll be offset by 0.1, and distance will be 2.8. And then just gonna simulate the head of the countersunk screw, which will still be partially poking out of the top because we can't use the countersink on one of the magnets in each pair. So that is sticking out. Worst case scenario, let's say 1.2 millimeters. And the screw head is like 6 millimeters. And then, just for completion, we're going to add the little hex tips, slots, head things, whatever. -2 maybe. And just -1. Okay. Let's go back to the appearances, and let's add the funny magnets in. I don't remember having to download these materials manually. Okay. So if you have those magnets, and then you have this bottom part, and it needs corresponding magnet things too. So let's protect those holes. These are also 15. And from here, start from here and go down. And here the countersunk screw head clears that, so we don't have much to worry about there. And that means that we can just use the straight up that, and we don't have to worry about epoxy either. So let's go with, just to be safe, 3 millimeters. I feel like there's another sketch here that's being selected. so start from this. No, start from that object. Yeah, I'm just gonna redo this on that side. Let's go 15 millimeters for that. -3. And then here, just go all the way. And then on the other side, we'll just use some nuts there. Not worried about that needing to be like super flat or something. You know, I'm thinking, just to make it easier to pull stuff out, we also kind of slot out most of the bottom here. And let's spread those magnets out then, so that they don't need to be, so that we have more room to do stuff. And let's actually make that 15 also. Never hurts to have a bit more room. Let's make that 10 actually. And then shaded with hidden edges, we can push that out much wider. Could we even do 40? Yeah, we could do 40 millimeters. And then don't want to go too far because I don't want to compromise too much strength on this. So let's, yeah, have that like 60. Okay, so this will be called bottom, and this will be called slide shim. Slide shim. Why can't I rename that? Okay, there. Cool. So have those in. We can model the other magnets. Sketch plane on there. Okay, and what's the diameter of this again? 14.6. Offset 0.1, and just do 2.8. Okay, so those are those magnets. And then, what else? So that means we can do this in, like, 4 panels. I guess, let's just look at what the assembly looks like now. With everything put together. Okay. We're still hiding that shim? Yeah, we are. Okay, so when the shim is in place, and let's just constrain that while section analysis. I meant to do mid-plane. Okay. Do we already have a section analysis? We do. Okay, well, I'll take that. Okay, so the way this works, let's take this out of the box first. Okay, so the box is taken out, and we have our thingy. And let's slide the shim out, which is gonna be. You know, actually, if we... I think we can do a thing where, well, no, I'll do it the sloppy way. Copy. Okay, so this is probably the janky way to do it, but it's okay. We'll just, so this will be just the shim, I guess. Which means here for the base, hide the shim and the magnets, and then it doesn't exist anymore. And then let's put the shim in here. And let's constrain that to there. Constrain that to there. Oh wait, that's not a constraint. Constrain that to there. Okay, so we can kind of visualize this now. So this is the default state, and there's no box in there. The box can't really be put in like this. Actually, this is closer to the default. So box can't be put in. We pull out the thingy. Let's just do it all the way. And then we take this all the way. Take this, and then we can put the box in here, and it sits down here. And then we take the shim and we push it, and then this will just kind of sludge it up just a little bit each time until it's at the height that it should be. And then it snaps in with that magnet. And then at first I was thinking of having like a little pull-out tab here, but I think actually now that we have this bottom groove, we can actually just cut a groove out of there and it'll be a bit more streamlined. So yeah, let's go back to that base thing. Take the shim. And yeah, just a finger hole that big should work. -10. Or no, sorry. Well, -6. Yeah. So then that'll mean that's gonna be like 2. You know, actually, that doesn't even have to be. We can have that punch all the way through. That's not a problem. Okay, cool. So yeah, that means that this thing has a little hole that we can use to just pull it out easily. And then I think the last things were just some kind of mounting for the so we have the mounting for the little bottle holders, so we just need to have like electronics mounting point here, which I think I'll just do an array of holes so that we can be modular with how we want to put the electronics in. have like some countersunk screw heads so that we can swap that out, and so it'll be flush against the box. And then I mean, honestly, don't even have to really worry about the wall mount stuff on this exactly, because we could just attach it via using these things, although it doesn't hurt to add more holes. Let's just add more holes anyway. Yeah, that's not a problem. Okay, so I don't know where I want to put this. I'm not going to worry about the wall mount, but I will put holes in here so that we can wall mount it when we want to. And I think that it'll just kind of do double duty, where the same holes that we use to mount the electronics will be the same holes that we use to attach the wall mount stuff. Yeah, let's do that. That seems reasonable to me. Shaded. Okay, so just gonna take that point there, and this point all the way up here. I think this is one of the strengths of Fusion over, what's it called, SolidWorks, is the rectangular pattern. You can actually do, like, you can do, symmetrical patterns. So yeah, let's maybe make 5 by 5. And then 60. Just want to make sure that doesn't line up along there, so 60 won't work. 50 won't work. I think we just have to live with 50 and just not include those holes then. 50 by 50, that sounds sane to me. And then that means that each of these holes should be 25 millimeters away from each other, I think. Let's see. Yeah. Alright, so let's add the countersinks, and then I think this is actually kind of done, and I think I want to wrap it up maybe tonight for now. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Countersunk by 2.5. And then on the other side, can do the same. Now I do realize that I could pocket these out to like save on material, but at the same time, since it's gonna be 3D printed, it's not gonna be solid anyway. So just by having infill, like, naturally pockets it, and I kind of want just more flexibility for mounting versus having to save the material. I also just bought like 4 kilograms of I just bought 4 kilos of black PLA plus, so as far as I can tell, I feel like that I am currently filament rich at the moment, so yeah, I don't need to worry about saving on that. Okay, so let's update this. And that means that the last things to really CAD are just going to be whatever electronics mounting we do, which will just be probably a simple box with like 4 screws along here, probably. It'll just be electronics mounting, and the, what's the other thing I was thinking of? Electronics mounting and wall mounts, which are wherever it's gonna sit, which I have no idea where, so yeah. Figure that out later. But yeah, this thing up here already works, so we just need to print out the 4 side thingies and the shims. And, yeah. And I think I'm just gonna wait on that to finish printing, which today is Thursday, next stream is Sunday, so this will definitely be done, as long as I keep track of my, plates. And then, I'm gonna do the shim part first, actually. Actually, something that I like to do, this is a little trick I like to do, is, if I want to do a test fit of something, which right now the magnet stuff is a really good idea to do a test fit for, I like to put just like, this is just temporary. This gets deleted after, I figure it out, but this is the section that has the magnets, for example. We don't even need all of that. And just like take this chunk. So I like to do that, and then just take this big ass thing here. Just delete all of that. Well, what the fuck just happened? I thought that was gonna cut through everything. Why did that not work? Okay, let's hide this stuff then. Just slide shim and bottom. Okay, let's try again. Oh, I didn't highlight that stuff. Okay, so then we have just this little tiny section of parts, and then I can just export that and 3D print, and then in like only in probably like 10-15 minutes, I can just sanity check that the magnets are the correct distance I thought that they would be, and the correct fit. So I'll just go, I wish that the 3D print thing would let me just send multiple objects, because like having multiple part prints whoa, why is my hand doing that? Oh, it's been doing it the whole time. I think I had my tracker on backwards. Oops. Okay. I think we're good now. Alright, so we can just call this one magnet test fit. Realize that's not the right thing. We want to do export. Magnet test fit, 3MF. Bamboo Studio. And then, wherever I put my Cradle of Pilth folder, I think I put it in the wrong thingy. Oh well. Where did I save it? Not save it where I thought I saved it. Oh. She was in the folder that it should have been. Magnet test fit, yeah. So instead of probably like a few hours, This should probably take maybe 15 minutes to print. 13 minutes, right on the dot. And then that can just go. But yeah, and then when I'm done doing that, just undo all that crap. And then we have all this stuff. And then, yeah, we have our model again. We just get rid of those features, or just kind of leave them in the void of never rolling back to it or something. But yeah. Okay, so I think let's get the latest version. Yeah, so we have those holes in there. And wiring, I'll do that once this is all printed, so that, and we have things assembled, so that, oh, you know, I forgot to put the, what's it called? Let's have these screw holes, but I forgot to put the, heat set insert holes in there. I'm not sure if I want heat set inserts, but I am running low on plastites. Oh. I need to consider that. Oh, that's easy. I'll just countersink. Countersink. Will that work? Will that be too tight to work? Nah, it's not, because it's offset enough. Okay, yeah, I'll just countersink that. But yeah, I'm not sure if I have enough plastites actually to assemble this. I should actually probably check. So I have like, oh yeah, I actually do have a ton. Sweet. Yeah, I have these guys. So I don't even need to do the heat set inserts, but I do need to adjust the hole sizes just to make sure that it's, yeah, that, wait, 3.58? Might be barely too small. I might need to change those to be like, 3 instead. So where did we make those holes? Okay, not there. Getting closer. I think it was here. No, it wasn't there. Is that too far? Yeah, that's too far in the future. Okay, so if we just reduce that down to 3. Oh. That does slightly change everything on the geometry. But it doesn't mess it up enough. Okay, that's good. Okay, so just need a few adjustments then. So this side, we definitely need some chamfers here, so that we can countersink. Let's make that like 2.5. Kind of overdoing it a little. And then here we need to surround out, because this is not long enough to go the full 15 millimeters or whatever that is. So, yeah, that'll need to be, like, sunken in some amount. So, whatever the head size of this is, that's 6.3. Let's round that up to 7. Equal. And then that should leave 5 for inside of the plate, and then about 8-ish millimeters into the plastic, and since we have 6 of them, that'll probably be enough. This is not a combat robot, this is not experiencing extreme loads, so I think that will be fine there. Yeah. Cool. How deep is that hole, actually? Okay, yeah, that's appropriate. Okay. It's a good thing I caught that before I started to, like, print them, and then realizing I can actually put it together, because the screw holes were messed up. Okay, I guess just one more pass on printability for all this. We'll make a group, we'll just call this one sensor stuff, and we'll call this one, base stuff, and we'll make a group inside of that called hardware. Okay, so that's also a magnet. That name scheme makes no sense. Okay. There we go. So that's all hardware. That is all sensor stuff. And then actually we need to make shim, because that's now its own separate object in the animation, not animation, in the assembly. Okay, cool, and then all of these just go here. Box right side. Box left side. And we have just these 5 objects to do. We have the top plate, the bottom plate, the shim, and the 2 sides. And let's just check them for printability. Okay, so the shim, if we hide the magnets. Hide the magnets. Support is only needed here, and we print it flat. And this is easy to, well, there's something wacky going on here. Where did we do that? I mean, maybe the slicer will remove it. Okay, I think it was here. Let's have it go to object. All the way there. Okay, so I think that fixes that. And I actually want to round that out also, just so that it inserts easier. Yeah, it's almost like a tongue. Ew. Let's do 40. Yeah, it looks like a tongue. So yeah, this, we only have support material going in there. That's easy. Magnets just tuck into there with 2 screws and epoxy. And then we have this top plate. We can print it this side down, so it's gonna be printed like this. And we don't need support materials for the chamfers because it's small overhang and diagonal. Exact same story for the box size, which I think are identical. I mean, I redid the operations, and I probably should have mirrored it earlier, or probably should have added the holes and then mirrored, but oh well. But yeah, that's a thing. They're just gonna print on their interior sides, and again, chamfers don't need to worry about the thingy. Don't need to worry about support material. And then this one should also be good. Let's print this side down, and again, small overhang, and it's diagonal, so don't need to worry about that. So yeah, this should all be 3D printable. Yeah. And just to sanity check the mechanics, we can insert the box gets inserted into there after removing the shim. Shim just goes back and forth, secured with a magnet, and when the box is in there, or just because of gravity, it's gonna live in there anyway. And when we pull stuff out, the forces are not really gonna make this push out. I think that's good. Cool. Oh, and I did clear that part so that the countersink, so that the heads can clear that. Yeah. Cool. Alright, let's do the thing I was talking about where we save this. And see how many plates it needs to print. I'm gonna guess 3 plates. If we're smart, we could do it in 2. So let's call this box base V1. Although, I'm gonna wait for the magnet fit test to finish first, which it should be finished very soon. Yeah, finishing up now. Okay, so let's do that. Okay. So yeah, it's gonna need 3 plates. I was hoping that we could like rotate that and then we could like shove this in here somewhere, but nah, that's not gonna work. And so, can we do like a total print time? Oh, we can do slice all. I didn't know that. Never tried that before. 8 hours. That is not bad in only a third of a roll. And that's default settings, and I just like to beef up stuff because robot combat. But yeah, let's... How much if we beefed up a bit? Okay, so not that much more. An acceptable amount. Okay, well, those just popped off the bed. Something got a little weird with, what's it called? The purge line thingy. But just as long as it sits flush, we should be good. Okay, yeah, that hole is definitely big enough. And that is flat. And, where are the, where's the countersunk? M3. Countersunk M3. We'll just screw this one in all the way. You might need to drop it down just another ½ millimeter or so. But I think that it's good. And just pretend that a nut's securing it on the other side. Okay. Yeah, that looks almost exactly flush. It's like basically perfectly flush. I think I'm gonna drop that just a 0.5 millimeter. And then this is our weird one, where it needs to sit in like this. And then let me take another countersunk M3. Ow. And so this one's gonna be kind of weird because, like, you know, we might not actually need epoxy for it, but I might also do it just in case. But yeah, just want to make sure that that locks in. Test fit is good. I'm just going to push that a little bit deeper. But I think we have a good fit there. Cool. Alright. So... wherever we defined that, it was in here. So -3, we do -3.5. And I don't expect the material to be so weak that we can't actually, like, do that stuff, and let's just kill the test print stuff. We don't need that anymore. We just need to do one little adjustment, and it's happy. And then let's export again. We'll just rename it the same thing so that we can just, like, do the refresh thing. Blockspace v1.3mf. Export, replace, yes. Reload from disk. I don't even know if that did anything, so we'll just re-import it manually anyway. Just be safe. Yeah, sure. Yeah. Oh, did I move something around by accident? I may have. Okay, cool. Yeah. Looks sane to me. And they're all gonna take about the same-ish time. This one just a little bit longer. Although, let's see. I know, I kind of want to pair these parts together just because they're meant for each other. So they're gonna be kind of picky about that fit. I don't think I can squeeze that in. I can't. I could be a gremlin. I could also print it standing up, but that seems kind of dumb. Maybe not that dumb. Nah, I don't want to tempt it. That sounds like just asking for a print failure. Well, then again, the really big, wide PLA prints, they do tend to lift. So it might actually be better to print it on its side. And then I'll just see what the cost of that is. If it changes, and we'll just use a really, really big fat brim on those. Oh, we are using significantly more because we have a lot more loops or walls going on. So that's basically gonna be solid panels here. Well, is that a bad thing? Yeah, that is probably a bad thing. Yeah, and it'll be... something at the layer lines, because... You know, I think we should do it standing up, because the screws are going to be going in like this. And so, if we do it sideways, it might actually split. Whereas, like, here, the countersinking heads do kind of wedge stuff. So, they're not gonna be that risky. We could also just set this to, like, 2 loops. And then we could have some infill on that. Oh, wow, yeah. That actually gets us pretty close to the original estimate, then. Yeah, I think this is actually the way to go. Just make that 2 loops on there, and add some big-ass fucking brims onto that. And then I think we're good. Yeah, 400 grams, not bad. Awesome. Okay, well, I'm gonna go get those prints started, and I think I'm good to call it a stream. Let's see. Guess I'll raid. Yeah. Okay, well, gonna log off. Yeah, I'll see y'all. Bye-bye.